Did you know that in many ancient cultures, the standard unit of length was called a cubit, and it was the distance between the elbow and the tip of the longest finger, so from here to here. And they took this measurement from their ruler of their country or their region. And that's why today we still call these things rulers. This worked to some extent, but the length varied depending on the age or the height of the ruler at the time. So this system was eventually replaced with standard measures. In this episode, I'm going to share with you a little history of our system of measures that's now been officially adopted in almost every single country of the world. And I'm also going to show you how the various units of measure are all related. And if you stay with me to the end, I'll explain how converting between units is being taught incorrectly. In 1792, the French decided to create a system of measurement that we call the metric system. So two French astronomers measured an arc from the equator to the North Pole that passed directly through Paris. They physically measured this distance with rods that were end to end, and these were the length of 1 toise, which is about 2 meters today. After about 7 years of work, they defined the length of 1 meter as being 1/10,000,000th the distance between the equator and the North Pole. And you'll find this official length in museums around the world today. From the length for 1 meter, they created all the other units for measurement. And I'll explain that in a moment. But let's look at all the other units of length first. The length of this block is called a decimeter because it is 1/10 the length of a meter. The length of this block is called a centimeter because it is 1/100th the length of a meter. And although I can't physically show you, the millimeter is so named because it is 1/1000th the length of a meter. There are longer measures of length too, some of which we use often and some of which we hardly ever use at all. Now length is a measure in one dimension. This decimeter is 10 centimeters long. Area, on the other hand, is a measure in 2 dimensions, and it measures an amount of covering. So 1 square decimeter is 100 centimeters squared. Volume is a measure in 3 dimensions, 1, 2, 3, and it measures the amount of space to be filled. So this cubic decimeter is 10 centimeters by 10 centimeters by 10 centimeters, which is 1,000 cubic centimeters. Now capacity is the amount held in that space. This little demonstration shows that this container holds exactly 1 cubic decimeter. So if I was to fill this container with water, it would hold exactly 1 litre. Now because it also has 1,000 cubic centimeters, that means that this little cube, if that was a container, it would hold 1 milliliter of water. Now that only leaves mass, and mass is the amount of matter in the space. So if we weigh pure water that fills this container at exactly 4 degrees just before it freezes, we would call that weight 1 kilogram. And that means the amount of water that fills a container this size would weigh 1 gram. This image summarizes all that I just shared, and I've added it to a link for you to download at a later time. And now for the error in teaching. When it comes to converting between units, we're often told to multiply or divide. For example, suppose we have 3 meters that we want to express as centimeters. We are told to multiply 3 meters by 100. Well, 3 meters times 100 is 300 meters, and that's definitely not right. So in short, if you multiply or divide meters, you will always get meters as an answer. So asking students to operate to convert between units isn't technically correct. I propose using a device like this to show that the process simply involves regrouping or renaming. Here you can see I have 3 meters, but when I close the expander, you can see the 3 meters is 300 centimeters. No operations are needed. And I can also show that 3 meters is 3,000 millimeters. I have provided one of these in the link, and you can also use it as a template to create other expanders for measures such as mass. So this is what I want you to do. 1, I'd encourage you to share a little history of the development of the metric system. It just helps to make mathematics more real and interesting for students. And 2, we want to avoid confusion and misconceptions. So use the expander that I provided for you in the link to help students understand what really happens when we convert between units of measure. And finally, if you've seen value in today's episode, leave some helpful comments and subscribe today so you never miss another learning opportunity with me. See you next time.